Welcome to this talk. AI is coming, now what? Architecting the future of software. So last year, it's about 18, 19 months ago, things got pretty wild where AI hit the streets, as it were, where we finally, people out in the real world had access to AI, and the pace of change has been nothing less than breathtaking over this period of time. So here we are into just about the halfway through 2024, and things are still just moving really, really fast. This all started back in late 2022 when OpenAI released GPT, their chat to the world, to the public, basically, at the end of November 2022. So AI research has been going on actually since the beginning of computing, so about, since the 50s, but it really didn't hit mainstream. It really didn't start to hit, millions of people until the last year and a half or so. And like I said, the pace of change is just spectacular. Just for example, this week, and this happens a lot. Google, I think, announced yesterday, the new version of Gemini 1.5, with a bunch of new features. And I think, and OpenAI seems to like doing this. I believe it was the day before, they announced GPT 4.0 with a bunch of new capabilities. So I watch a lot of YouTube AI influencers pretty regularly, and they're actually kind of apologizing for, like one guy I watch, he has a wrap-up of what happened this week in the AI news, and he says, this is getting to be kind of old, but we had another big week in AI, and it's been going on week after week after week for the last year and a half or so. So we know things are changing. In our business, and I mean, I'm a developer. First, I've been a developer for a long time, so my talk is really from the perspective of a developer and how this is impacting us as a community. But I think in the IT community, this is really a big deal. And it's actually a bigger deal than that, but for us, it's a big deal. So we know things are changing. And a lot of these, not a lot of them, all the images in my presentation were made by AIs. And I was really happy when this one came out, because it's a person, but it's like it's a sand sculpture. And the wind is blowing things away from that sand sculpture. And I feel that way. It's like my skills and experiences and capabilities and so on, I feel like, are they relevant anymore? Are they just evaporating with all these massive changes that are happening around us? And so we know that we're standing at the edge of a significant change. And in fact, many people that are really close to what's going on here, many people are saying that this is a very significant inflection point in human history. Inflection points bigger than probably any inflection point that we've gone through in human history. So things like the invention of the beginning of the Industrial Revolution with the invention of steam engines, and then electricity and internal combustion engines. Each one of those things had it brought in a pretty significant inflection point. Jobs went away, new jobs came up. Things changed very radically in society. I'm reading a book on AI, and in the book, the author was talking about like how quickly the internal combustion engine transformed from horse-drawn carriages to automobiles within a few decades. Well, now we're looking at probably the most profound inflection point, and I think maybe less than 1% of the population of the world realizes that now, but it's going to affect everybody, but it's definitely going to affect us. So I don't know about you all, but this is having a big impact on me. I'm sitting here thinking, okay, what's going on? I get this feeling of I'm worried, I'm melancholy, kind of sad about maybe what's going away. I come to these conferences and I look at what we're doing as an industry, and I'm wondering how much longer we're going to be doing things this way. But also at the same time, there's a lot of excitement. I'm an optimist, and so I have this kind of, optimistic hope about what the future may bring. So there's actually somebody that I watch on YouTube again came up with a name for this feeling, this weird feeling that I was having. And I watched this guy, his name is David Shapiro. These QR codes are to a couple of his talks that he did about this, but he coined this term called vesperance. And he defined this term as this feeling about, oh man, what's happening to us? You know, everything's changing. What I've been doing my whole life may be changing very, very significantly in the not too distant future. Many people are already starting to feel this, and many people that don't know it's even coming will feel this, probably not too far off. So this term vesperance is what he coined for that, and those two talks that he did are really interesting about this. But like I said, I'm an optimist. So it's not just about the machines, it's about how we, deal with this. And specifically, us in IT deal with this, and more specifically about how we build systems. This is a Java conference. We build back-end systems for the most part. How's that going to impact us? So I wanted to, talk about this. I wanted to cover some of these things. So the talk is in 3 parts. There's a first part is, I call it micromind services, and a kind of an introduction to this. You'll see what I'm talking about in a minute. Then part 2 is taking a look at AI coding assistants. I can't see the audience too well here, but I've queried other audiences when I've done talks, and I asked how many people use AI coding assistants, and usually the number of hands keeps going up. But like last year, I was at, say earlier in the year, some conferences, barely anybody was using AI coding assistants, but between then and now, more and more people are using it. But I still know that there's maybe 50%, it seems, are still not using these things if you're a software developer. So we'll take a look at that. And then I'm gonna go out on a limb and talk about maybe what I think, this is just me, but what I think might be coming in the future. So that's part 3 of the talk. So what I may mean by this micromind services thing, well, it's not really that wild, but what I want to say first is it's not about AI and ML. And I just want to bring up a point that when you look at the kind of software that's being developed for these new systems, these open AI systems, the large language models, those types of things, this is programming on a completely different level than what I know I've been doing for a long time, and I think a lot of us in the Java community have been doing for a long time. So I'm not, when I say it's a micromind, but it's not about artificial intelligence, machine learning, although there's going to be some overlaps, and that's what I want to hopefully point out. And to bring it back into a little bit of reality, it's really based on event-driven types of systems, and more specifically, what I like to think of as fully event-driven systems. So just to jump into it, I want to just kind of walk you through what I mean by a fully event-driven system. Well, the first thing is that in this diagram, this is a diagram of a demo system that I use. And it's not just a pretty diagram. This is the actual layout of the design of the system. So these diagonal boxes represent small, very focused, think of them as services. And I'll explain what the other boxes do. But from an event-driven type of a system, what happens is that a request comes into one of these services, the service may produce an event. That event may be of interest to other services. So what's happening here as I'm walking through this design is that you're seeing the propagation of event that came in the beginning there, but it's triggering kind of a cascading sequence of events. This is the real behavior of this application. And the fundamental capabilities are really just as this kind of event-driven flow. The demo is basically, it's like a little e-commerce demo, but it's not just taking in orders. What this demo is doing is it's allocating stock to orders. So this is what's happening in this flow. As orders come in, this triggers a flow of allocating stock to the orders, and there's a lot of really interesting behavior in this system. But what kind of blows me away about this design, if you look at the diagram, there's only 3 shapes and the lines that are in this design. And these are the 3 shapes. So those diagonal boxes, I call this, think of it as a simple service, is also known as an entity, because it really is kind of a durable, stateful object. It's a single object. It's not super complicated. And then the V-shaped things are views. So these are queryable views. And if you're familiar with CQRS or command query responsibility segregation, this is what it is. And then the third component up at the top there is called an action. And the actions are, in this case, what they're doing is they're subscribing to events, and those events come in as they're being created upstream, and these actions transform the events into commands that are sent downstream to trigger reactions from downstream entities. That's it. This whole system is built using this pattern of these three components. The micromine thing, and this is where I'm pushing things here. Look, I'm having some fun. But conceptually, it reminds me, because I'm really interested in artificial intelligence, neural networks, biological neural networks, artificial neural networks. I think there's something that's really profound there. And what struck me as I was working on these kinds of systems is that these entities seem to be somewhat analogous to neurons. Signals come in, they trigger some kind of a change, signals go out. That's basically what a neuron does. These actions are something like a synapse. And a synapse in a biological neural network is the junction between two neurons. A neuron emits a signal, the signal goes into a synapse, and the synapse triggers the signal to go downstream to another neuron. That's what these actions do. So I don't know. I felt like there's kind of a relationship here between the makeup of this kind of system that seems to have some similarities to the power of what we're learning about the power of these neural network types of systems, which are extremely powerful. So this is just the behavior of this system. It just, signals come in, signals go out, they trigger other things to react to them, and I built a system that does things like I said, orders come in, it goes looking for stock, and it's not just, say, decrementing inventory counters. This system, this little demo application is tracking every single physical unit of stock that's being allocated to orders. All this information is being captured. In addition, this system has the capability when an order comes in and there's insufficient stock, the order goes into a backorder state, but that triggers and kind of an alert to other parts of the system that, hey, we've run out of stock here for this product. That triggers orders for inventory to come in, and when the inventory comes in, the inventory goes looking for back orders and allocates stock to the back orders. There's only 13 of these little neurons in this system, and all this behavior is packed into this. And when I kind of got into this kind of pattern, it's like, man, this is kind of powerful. And this is kind of like what I'm seeing with these biological networks. So this is, like I said, I'm pushing concepts here, but this is why we're here at conferences like this. But I want to show you a little demo that I did, or I'm sorry, a little video that I did of this application I hope you can see it, in action. So what's happening here is I grabbed the log from this application as it was processing orders, and what's going to start up here in just a moment is now it's processing 200 orders. These circular regions, each dot represents a unit of state. Each line represents an event coming out from one unit of state, one of those entities, going into another unit of state. So what you're watching here is stock being on the right, which is kind of in a bluish color, being allocated to orders on the left. And as things turn green, that means all the individual orders and all the parts of the orders are being allocated stock. The red, it was indicating that orders that were for a short time were in a back order state, and then the process goes. But this is real log data that I took and wrote a little bit of code using Blender to do this video to show this system in action. And I did it deliberately because often, I don't know if you've seen videos, but there's been videos of like neural networks in action. That they've done videos of, say, neural networks of insects in action, and it very much looks like this. And it's like, okay, this is where I was starting to think, I'm building this little micromine when I'm doing this kind of event-driven type of a flow. So that was fun. And actually, by the way, I used ChatGPT to help me write the code that generated this video, took all the log data and write the video. So the idea is that this this event-driven processing that we're doing here is, I think it's biologically inspired in a way. It has that similarity to the way these neural network patterns work. And with neural networks, a fascinating area. But basically, you have, they say we have 86 billion neurons in the human brain. And there's trillions of synapses, because each neuron can have, typically a neuron has like 10,000 connections to other neurons. In any case, but mechanically a neuron is really simple. Signals come in, and that may trigger a signal going out. Doesn't always trigger it, but signals come into a neuron, signals come out. That's how your brain works. That's how basically artificial neural networks work as well. I mean, artificial neural networks have different ways of working than biological ones do, but the fundamental there is these neural networks. And what's really, again, kind of blows my mind, there's this elegant simplicity to this approach, but it has profound cognitive complexity and stunningly powerful capabilities. And I think this is what is so compelling here. Another way to think about this is that our biological neural network came on the scene on planet Earth, and humans basically took over the Earth because of our brains. Now, we have artificial neural networks coming online, and we're seeing another revolution occurring. There's kind of a pattern here that this processing pattern of this neural processing pattern is extremely and stunningly powerful. So back to reality, though, you have requests coming in. These are often called commands. Commands may trigger events. Events go into these actions, which transform them into another command. They're mechanically similar to a synapse. And this is how you can build these kind of event-driven types of systems. These entities are, like I said, they're just wrappers around state. Like here's a shopping cart, and I just dumped out, an example in JSON. It's just an object. It's a shopping cart. It has a list of order items in the shopping cart, basically. So how does this fit into this new age of AI computing? Well, like I said, it's modeled after these simple networks of neurons. And these simple components really work well with these emerging AI assistants, these AI tools that are rapidly coming on the scene. So this AI-assisted development process, it works really well with this kind of thing. So in a way, programming becomes this prompt-oriented coding style, where you're in an IDE of your, like I use VS Code, and I'll show you a quick example if you haven't seen this before in action, but you're in an IDE and you just start typing, you're basically prompting an AI, and the AI writes a bunch of code for you. So these AI assistants work well with reusable patterns. And the design diagram I showed you, there were 3 patterns there, those 3 components used over and over and over again, and there's other patterns. But at the code level, you can see, like here's 3 APIs that are defined. You can see the annotations like put mapping, patch mapping, patch mapping. But if you look at each little block of code, they're just kind of reoccurring patterns. And again, AIs love this type of stuff. But here's where we come in. I don't know how long this is going to last. I don't think anybody does. But I think for a while, might be years, it might be longer, who knows, that where we come in as humans involved in this process is that somebody has to understand the big picture of an application system. An individual or a team like we do today, but the process is we have the capacity to have the big picture, all the nuances and everything involved. So we're really good at having that big picture, and then also using reusable design patterns. And I want to show you a few patterns kind of that have emerged in this processing flow. So the first one what I've shown you so far is basically a saga pattern. And there's actually 2 forms of saga pattern. There's orchestration saga pattern, which is a workflow basically. But here's what's called the choreography saga pattern. A choreography saga pattern is there is no controller. The flow of sequence of events is basically a natural behavioral characteristic of the software system itself. Most people that I talk to kind of go, well, isn't it better to have a workflow? And I say, yeah, workflows are great, but it's probably because of our training. We're used to the kind of the imperative approach for doing software development. But what I think is surprising, because I like pushing through into unknown territory, and getting into these choreography flows I found to be as easy to think about and think through, especially when you can see them visually like this, that they're relatively easy to understand. But there's other patterns, like one event, I call it one-to-many. One event triggers multiple commands going out. So for example, an order comes in, that order has a list of order items, so you're not sending one command to one thing to allocate stock to all the order items. You're doing one per product, one per item. So you're firing out commands to multiple other entities. There's another pattern that's called a generation loop. This is where something emits an event, but it loops back on itself to tell it to keep working on something until it's processed everything. But it's kind of done through this indirect looping mechanism. A big one here is what I call just a reduction tree pattern. And basically, this is just a tree pattern. So the leaves of the tree are detailed information of some kind of, like, you're allocating inventory, but you want to have an inventory count so that those leaves of the tree work down through the levels of the tree, and the trunk of the tree is the count, like how much inventory has been consumed for a given product, something like that. But the stunning thing here, I think, is that in this little design, there's 13 entities, and this pattern came up and I found useful in 4 of the 13 entities, this reduction tree pattern. So what I like about this approach is that it seems to be a more disciplined system design process. I'm limited, but in a way in that you only have these like simple components and these simple patterns, but I don't feel limited. I feel liberated, actually, when I'm thinking through designs of this type of a system. But there's kind of a simple, formulaic discipline to the whole process, and it's transferable. I mean, so for example, here's the design that I've showed you before, but here's another design, completely different application. But the thought process is very similar. The patterns that I quickly showed you here, and there's more patterns, are here as well. Reduction trees, one-to-many, generation loops, all these different types of things. Patterns that I really haven't run into before in the typical, like CRUD-based imperative type of programming I've done for decades. So this is where the reusability comes in. And as a kind of a big example here, this is, there's 2 demos here. One is called Earthship, and that's where it's shipping orders. And another one's called Transactor, which is, so in one case you're allocating stock to orders, in another case you're allocating funds. Withdrawals are consuming deposits, whereas orders are consuming stock. But the processing pattern you can see is similar. And not only is it similar, but it's symmetrical, meaning that what these 2 things do, these 2 entities do, is in one case, orders are hunting for stock. In another case, stock is hunting for orders. With the Transactor demo, the withdrawals are hunting for deposits, but in another case, it could be deposits are hunting for withdrawals. So there's a symmetrical processing flow. And this is a Saga pattern. There's contingency flows and things like that built into this. But at first I thought it was going to be really complicated, but it turned out it wasn't. And then I found out it was reusable. And it's like, okay, there's something really interesting going on here. The thing I liked about this is when I got systems working, they just kind of worked. I didn't have big issues with it once I kind of knitted all these different components together and they started processing things. And it's based on principles that we've been talking about a long time, more specifically with things like microservices. With microservices, we say do one thing and do it well. Loose coupling, use asynchronous communication as much as possible. Isolate state. A big one here, though, is processing occurs across space and time. And what I mean by this is that these entities They don't know who sent it commands. They don't know who consumes the events. Each individual entity doesn't care about the rest of the system. It doesn't have to care about it. All it cares about is its own little thing. It reacts to commands. It does some processing on the command and emits events. That's it. So one entity could run on a machine over here, and another entity could be running on a machine over there because they're loosely coupled and they're talking asynchronously. It doesn't matter if service A and service B don't have to be up at the same time. This works really great in distributed environments. So moving on, part 2, AI coding assistance. So there's a lot of coding assistants out there. There's more coming online all the time. Like I mentioned, I use VS Code, and one of the things I like about VS Code is the extensions, and there you can easily go in and just take a look at all the different extensions that are out there. One thing to look at is the number of downloads. So like this Codium is relatively new, and it's got a fairly small, it's 648,000 downloads. But you get into something like this one called Tab 9, and it's got almost 7 million downloads. This is as of a couple months ago. Amazon, they have something called Code Whisper, a couple million downloads. Another one that just came out recently, Pythagora. I was kind of seeing some chatter about that online, that people were starting to like it. So that one's a new one, very small. But then you have the big one, which is GitHub Copilot. It has just over 14 million. It's probably getting closer to 15 million now, because it seems to be growing pretty rapidly. And then after Copilot's been out for about 2 years now, and they introduced Copilot Chat, which I'll show you a little bit of that in just a moment. That's got over 8 million downloads. Here's a fork of VS Code. That's this company called, they have this thing called Cursor, and they call it's VS Code, but it's an AI first code editor. This one's very controversial. I don't know how many of you heard about Devin. Devin hit the scene some months back. They exploded out of nowhere. They released some videos that everybody got really excited about. They were calling it not a coding assistant, but an AI software engineer. The videos looked very compelling about the engineer, but then somebody else did some tests on that and it was refuted. So there's been a lot of controversy about this, but that's to be expected in this wild and woolly world with AI right now. So if you haven't seen an AI in action, here's the chat. On the left, what I did, I hope you can read it, but I'll just read it out loud. So I put in a prompt. I said, using the currently open file as a reference, create a new class named shipping orders view. The class contains 2 queries, one query that selects by customer ID and another query that selects by shipping orders from and to date. And it says, sure, here's your code. And it dumps out the code. You can see, hopefully, it did a whole bunch of code for me. All the annotations, the imports, and also the SQL. And what I did was I said, hey, take a look at this view that I wrote before and use that as a guide for writing a view. So it's kind of writing this view in my style. You're copying my style of writing a view. That was it. And I was very grateful because those things are kind of tedious to do. I just want to show you real quick. I'm in an IDE and I need to add another API. So I just hit enter, and it comes up and it shows this kind of ghost code. It might be hard to read as grayed out, but it's called ghost code. But if you just tab, it goes, yeah, that's what I wanted. And this is the bigger one. I hit tab again, and it wrote the method. So the AI knew that there's a missing API for this backorder API. And it knew it because there's Java records later on in the code for the command and for the events associated with this particular API. So it deduced from that information and it wrote this method for me in my style, right? So, I just basically hit enter and tab a few times and I'm done. It doesn't always get it right, but often it does, and it's like, it's in my head. It's reading my mind. It's quite amazing. So the last part of the talk is where I go, like I said, way out on a limb. I don't care. I'm predicting the future, so it's bound to be wrong. But the idea here, and I, there's a lot of people thinking about this in one way or another, but I want to push things a bit. And so I'm calling it test-driven prompt programming. So we've been hearing about prompting a lot, but I wanted to add in the test-driven part for a very specific reason. But first, imagine that the source code becomes your prompts. Though that's what we check in. It's the source code. These AI prompts are our new source code. Today, what's happening is we prompt these AIs in one form or another, and they generate code for us. GPT is generative, pre-trained transformer. Generative, right? That's what they do. So they generate code. But what we do is we keep the code, because that's what we're used to, when we throw away the prompt. What I'm proposing here is that it's flipped. We don't even look at the generated code. I'm predicting, we'll see if this is true or not, that in the future, and the not too distant future, we won't be looking at Java or Scala or Kotlin or anything like that anymore. And there's some precedence to this in history, because there's this really great talk that that's on YouTube, and it's about 10 or more years old now, but it was by this guy named Brett Victor. And he did this talk where he pretended as if he was a developer. I think it was like 1973. And the talk was done in 2013. So he was pretending that he was a developer talking about coding in 40 years in the future. He even dressed like a developer. He had a pocket protector. He had an overhead slide projector with transparencies, the whole 9 yards. But he did this fantastic talk. One of the things he talked about was a uproar that occurred when we went from binary programming in zeros and ones, to assembly language programming. There was an uproar. Oh, wow. The binary programmers just couldn't believe we're going to use this newfangled assembly language programming. But then assembly language programming came along. And then languages like C and Fortran came along. And guess what? There was another revolt. Oh, I need to have the control of the machine at the assembly language level, which is what the binary programmers said, by the way. I don't want to give that up. So now here we are, 50, 60, years in the future. And do you look at assembly language? Do you look at binary? I don't. I have in the past, mainly out of curiosity, but we don't look at that stuff. We don't look at the generated code. So this is what I'm proposing here, is that imagine, maybe in the not too distant future, that our expertise as developers, as designers and implementers of software systems is in the expertise of creating prompts to articulate what our software systems are supposed to do. So these are human and machine readable AI prompts, but they're done in a way that is not just articulating what the system should do, but it's also more results-oriented, and it's test-oriented. So for example, you're explaining something that should be done, but you're defining it. Your prompt basically says, yeah, and when this input comes in, I'm expecting this output, maybe something like that. But the AI can take that information that's sufficiently unambiguous and generate code from it, and also generate tests. So the validity of the generated code is backed up by passing the tests. And if it doesn't work, then our job as human developers is we go back and tweak the prompts so that it does what it's supposed to do. And the big thing is this, and so the process is still, I think, iteratively developed. Your prompt, like today, I think they call it zero prompt. You just go into an AI and you give it a single prompt and you expect the output, and that's it, you're done. But more likely, it's not that way at all. In fact, the style I've been starting to adopt in interacting with AIs, and I use them almost all the time now for writing code as well as writing text, human readable text, generating images, things like that, is that I warm up the AI. We have a conversation. And I'll show you an example of that in just a minute, but it's a back and forth. You want to get the AI kind of, and your head into the space of what you're trying to talk about as you're developing something. So go imagine when you're defining a system, you're in this, you and the AI are interacting with each other, and you're having a conversation to get to the point where you agree that this is let's generate some code and some tests and see if this works the way we want it to work. When it doesn't, you go back and tweak it until it does. So here's an example of this. So I've been thinking about this concept. I'm not going to, I wish I had the time and ability to do this, but I'm waiting for somebody to do this, basically, to generate or create these kinds of tools. But what I wanted to do is show you an example. So in this session, and this was with OpenAI GPT-4, I had one of these conversations. I warmed it up. I was explaining, and we discussed what I meant by test-driven prompt programming. So once we were both kind of sufficiently into the conversation, I said, please provide an example test-driven prompt, such as the process of a customer adding an item to an order, such as adding an item to a fast food order. And it comes back and says, here's an example of a test-driven prompt. So it comes, and this is where it blew me away, because I just gave, my little prompt was just this 1 or 2 sentences, right? Because I was kind of dreading, how much detail do I need to add here? But the AI comes back and says, all right, here's the prompt, the test-driven prompt. It says prompt, functionality, add a item to the order. User story, it adds a user story. As a customer, I want to add an item to the order. Input specifications. These are the fields that are expected in the input. Expected behavior, it started to give some expected behavior. And just as an example of where this prompt probably needs to be tweaked, this very last comment, it says the system recalculates the price of an order. And there I thought, okay, this was just like a sample run, but I thought, okay, in a real prompt, I probably need to go in and add more detail, like what is the process of recalculating the total price? What's expected? It could, the process in one location of the world would be different, say, than another location of the world. So that's kind of an ambiguous part of the specification that needs to be more specifically defined, so it becomes unambiguous, so that the system creates that algorithm for computing the price in the correct way. But then it goes on, output specifications. It gives a list of the order items and the updated total price. It has some constraints. And then the last one, this is where I was really happy with what I saw, is it came up with some test cases. And so what's happening here is not only am I working towards having this prompt to be my source code to generate the code for the system, but I'm using the AI to write the prompt in the first place. So it's a very kind of turbocharged process here, if it works out this way. Again, I don't know if it will, but it looks promising. So questions that I get is like, well, what about, do you trust the tests? And I guess some of my responses to that kind of a question is that, well, okay, imagine you are the leader of a team and you're giving different members on your team the responsibility for doing different parts of the system, and they have the responsibility for defining the test and implementing the test so that the system is sufficiently well tested and it's ready to go into production. So you have this level of trust that you're delegating this responsibility to somebody else to do the work. This is basically what's happening here. The only difference is that you're delegating it out to a machine versus a human, right? Ultimately, the system goes into production once everybody feels satisfied that it's behaving correctly, but then it goes into production, you find issues, and those issues have to be resolved. So I'm not sure that there's a huge difference in the overall software development process here, other than what we're doing as humans is we're doing our source code are these sufficiently unambiguous prompts. So imagine a system like this. It's not like it's a single prompt for this entire system. Think of it more, let's go to the other extreme. There's a single prompt for every component here. Well, there's 13 components. There's 25 of these actions, and there's a half dozen or so, or dozen views. So each one of these things is defined as a prompt. Maybe some of them could be a single prompt for a small group, a pattern, like that pattern of those two entities that were collaborating with each other, one, an order hunting for stock and that whole thing. But in any case, you imagine that the source code of your system is a collection of prompts, each one building a certain small part of the system. This is why going back to this approach, where you have these small, focused, pattern-like components that fit well into this overall type of approach for building bigger systems. But we still have a big job to do because we're the ones, the humans, that understand what's the entire system supposed to do. So this is where I mean these patterns like this, and I'm making these names up, but I just wanted to label them. It's like called a transitive transaction pattern, because what's happening here, just getting back into the event-driven, I got a few minutes to do this, is that these operations aren't happening as a single atomic transaction. We have an order item come in. The order item emits an event that says, hey, I've created, which implies I need stock. That triggers a request to go to stock, a stock order item. And a stock order, if it has stock, it emits an event that says, here's some stock. But those are two completely separate operations that happen at different times in different space. Ultimately, the system converges on a consistent representation of the order has stock and the stock has been allocated to the order. But it doesn't happen in a single atomic transaction. And we have the code, the actual source code that gets generated is following these patterns as well, like these patterns of APIs. You can see that there's a bunch of event handlers here, but all this is very much a pattern. This record of state, this is the actual real state of the object, basically. The state is the object. They have relatively simple, repeatable patterns. So the result is you have a system composed of tightly focused, loosely coupled components that produce surprisingly powerful processing behaviors. And so this kind of neural network approach for doing software, which is basically event-driven types of software. By fully event-driven, which I said in the very beginning, the data is the events. It's not, the events aren't kind of the other approach is where you say you have a CRUD transaction that goes into a regular database, so you're performing some kind of normal database transaction, and then you throw a message over the side to Kafka. In this case, you don't do that. The data is the events in the system. That's the difference between, say, like a hybrid type of event-driven versus a fully event-driven. So I don't know, is this crazy thing of test-driven prompt programming the future? Are we going to be developing software that we don't look at the Java anymore? Another thing I've heard is like, well, we have all this legacy code, like we have mountains, millions and millions and millions of lines of COBOL that all these organizations that own that COBOL code are terrified of touching, because the COBOL developers, I was a COBOL developer, I'll admit it, at one point in my career, a long time ago. We're aging out, right? So what do you do without COBOL? Well, guess what? These AIs can go in and look at that source code, figure it out, and transform it. That's basically, the source code is the best specification, right? So you take that source code in one language and you transpose it into another language. And guess what? Also, by the way, the AIs can explain what that code does in a human readable form, which bubbles up to maybe these test-driven prompts. The source code becomes, is the AI prompts, not the generated source code. In any case, this whole idea of I think a lot of times I hear people talking in our space, in IT and development, talking about, well, yeah, we'll be using the tools, these AI tools, to help us write the code. And what I'm proposing, again, I've said it multiple times, but just to kind of leave you with this, is like, think about, because we're going to have to deal with this, right? Probably, in the not too distant future. Think about it where we're we're not dealing with that source code. I think for a while, maybe, who knows, could get us through into 2030s, it could get us through into the 2050s, but I think that there's a place for us in development, even in that kind of a world. So we'll see. So we went through the three parts, the micromine services, the big kind of aha for me, and why I wanted to talk about this was this connection between how we, non-AI programmers, can write code that has some of the powerful characteristics of what our brains do and what the artificial intelligence do. This kind of neural way of writing software, I think is very, very powerful. We took a look at these AI coding assistants, which are very capable today. They're getting better very, very rapidly. I know a lot of people, for a lot of good reasons, still haven't been able to adopt them yet, but you probably will be very soon if you haven't already. And then the third part, I went crazy on you all, where I said, I'm talking about this whole different way of thinking about writing software. So we started out with the word vesperance, this kind of weird feeling I know I have about where we are in this inflection point. I think all of us will remember this time in the early 20s for the rest of our lives, because it will be the time when things changed. These few years, we're in the beginnings of that right now. But I want to leave you with a little bit more, hopefully optimistic word. I would try to invent a word, but I couldn't. But so I'm borrowing a word. It's innovera. It's out there. But what I wanted it to represent was the feeling that I get, and I know other people get, when you work with these tools and it does something really good for you. It does a lot of work for you. Like it writes that block of code and you go, damn, that's exactly what I want. Thank you very much. Move on. Or you ask it to write some text for you, or ask it to generate an image, or whatever it is, and the AI surprises you with its capability. I just have that kind of reaction over and over again where it's like, yeah, man, okay, work done, move on. Work done, move on. I like it. So this is what I meant. I like the term innovera. This can't be said enough. I've been saying this for a while in some of my talks. I kind of pulled it out, but I thought for this talk, I wanted to bring it back in. It's not going to be the AI replaces us, it's the people using AI will. So imagine the new developers coming along that are doing test-driven prompt programming, replacing people that are doing programming as we are today. This one's even bigger, I think, is that you have to be willing to unlearn. When I was going through this process of going from decades of how I programmed back-end systems, and I've been using Java since it came out. I've been using, like I said, I use COBOL, all kinds of different languages, but I've been building back-end systems for a long time. I came into this new world, this kind of event-driven world, and I was throwing old patterns of doing things at it, and I was running into kind of brick walls. Oh, that wouldn't work because this wouldn't work because, and so what I was realizing, I had learned these behaviors, but I unlearned them so I could learn something new. This is a critical skill for us now. If you want to stay in IT, if you want to stay in this business, I think this is probably the most important skill you can have, is that ability to give up on things that were hard-earned, our skills and experience that are evaporating away behind us, but give up on it and be willing to learn new things. So the top right is the QR code for the slide deck, and this talk was inspired by something my company, Lightbend, does. It's called Calyx. So the software I was showing you is all about Calyx. If you're interested in that, the QR code in the bottom center is for Calyx. I think we're out of time, but it's the last talk of the day, so if you guys are willing, and if there's any questions, I'd be happy to take them. A lot of questions? Oh boy.
So we don't have time for all, but at least for a few.
Okay, thank you. So the first question, do you think that in the future AI will replace us? I don't know. I really don't. It's really hard to say. it's impossible to predict. This is why I'm kind of almost addicted to watching some of these people online that are talking about AI. I do know that what we do and how we do things is going to change. That I'm pretty convinced of. So this is why I think that unlearning and relearning, how do we fit into the future, is really important. Replacing us, it can't totally replace us, because who's it going to sell to? We got to be able to buy stuff, right? So I think we fit in there somewhere. Today we press the tab and we understand the generated code just because we're used to writing that code ourselves. How do we keep understanding when we're only generating a test or everything's auto-generated? I think the results is in the results of the tests. Like I said, imagine you are the team leader and you have a team of developers, which is the AI. You're delegating responsibility for building the system, doing what it's supposed to do. So basically what you're doing is you're giving all the developers specs, these AI prompts, and you're expecting them to write the code and write the test and have it work. And you're trusting that they will. How do you verify that their test and generated code is working? Well, it's the behavior of the system itself. So is there a really big significant difference there? Currently, AI suffers from hallucinations. Yeah, hallucinations is a big one. And there's a lot of work going on with that. I've seen multiple people working in that space that have been talking about this as one of the big things that they're working on, because they know that our level of trust of the AI isn't going to go up significantly as long as it keeps making crap up, right? When it doesn't know the answer. So now often what you'll see is people prompting AIs and expecting when it doesn't know the answer, it says, I don't know. I need more information, or I don't know. So, but that's a big area of work. The generating code by the AI from a prompt is non-deterministic. How to overcome this in a real system. I'm not sure if it is non-deterministic, because this is where I add the test-driven part, right? That in your prompt, you're defining, in a human language, you're defining what you expect the behavior of this part of the system to be. You're articulating that to a sufficiently unambiguous level of detail so that it uses that information to test the system. So when the system doesn't behave the way you want, it doesn't give you the output that you expect, you go back and you tweak that prompt. You tweak what you expect it to do. That becomes part of the system of record. Just like now when we see a bug, we create a test to reproduce the bug, and then we generate the code. So in this case, it would be, there's a bug in the system, or it doesn't do what you want, you go back to the prompt and you tweak it until it generates what it's supposed to generate. One last question? Yeah. Okay. Let's see. Copilot is the most popular one, but you think the best one? Oh man, okay. That's a good one. I think there's a mad race on for code generation. Gemini, now the name escapes me. There's three big ones, OpenAI, Gemini, and darn, I forget the name now. I use it all the time. But actually, Gemini has come on really strong. Each one of these things generate code now, and they're getting better and better. Now what happens, there's another guy I watch online. Whenever a new version of an AI comes out, he's got a battery of tests that he does against the AI, so he can test how well it does things, including writing code. And because what he's testing is the ability of the AI as it evolves and how much better it's writing code. And I think there's no telling. I mean, I think Copilot has a big head start, but there's a lot of people know there's a lot of money to be made here, and there's a lot of push. So the fundamental large language models are really good at generating code altogether. It's the tools that integrate them into our development process. But now you can imagine these tools that can write code, that have a level of functionality on top of them where we're not even looking at the generated code anymore. That's one of the things I'm proposing might be coming, but we'll see. But I don't know. I think nobody's the clear winner, and I think it's a horse race. Different companies will be taking the lead. Okay, time's up. Thank you very much for staying here for the last talk, and I really appreciate the questions. Any other questions? You can track me down, and I'd love to chat with you.